Welcome to my final project for CS50 programming. I wrote a program called Python Sequence to Structure, or PySeqSt, that converts amino acid sequences to three-dimensional structures by querying public databases. Okay, let me demonstrate how my program works. The program accepts command line arguments, and to see the usage you can run it with -h, and it will tell you the usage, and of course there's also a README file with further information. I'm going to be running the program on a file of 3 protein sequences in FASTA format that you can see here. And to do that, I execute the following command. And I get a message. So apparently the last of these sequences is not a valid protein sequence, and it asks me if I want to fix my mistake or if I want to continue. And I'm just going to continue. And so it loads the sequences from the FASTA file, and it runs a BLAST using the NCBI web server. And it also created a new folder called out, where it will save the output. So while the BLAST is running, let me tell you what the program is going to do next. So once the BLAST is finished, it will save the BLAST in the output folder, and then it will go through the BLAST to find all the PDB entries corresponding to the sequences that we've provided, and it will also look for any accession numbers that correspond to the sequences that we've provided, and it will try to account for any sort of tags. You can see I have some his tags in some of the sequences. And then it will take the accession numbers and it will convert them into UniProt, because they are from various different databases, and it's just easier if it all gets converted into one sort of language, so to say. And then it will actually take those UniProt accession numbers to query the PDB itself to see if there may be any PDB entries that we've missed, because maybe they had some sort of tags that the program couldn't account for. And then it will look for any structures for which there is no PDB entry. It will actually go to the EBI AlphaFold database, and it will try to find an AlphaFold model in there using, again, the UniProt accession number. And then once it has found all the structures it can find, it will then create a bunch of folders in the output folder, one for each sequence, and it will save all the different structures that it could find. So either the PDB crystal structures or the AlphaFold models. Okay, and as you can see, actually the BLAST is taking quite a while, and that is just because we're using a public, and it actually just finished, and you see all the next steps are actually proceeding really quickly, and it's saved all the different crystal structures very, very quickly. And so you can see for CVSTA, apparently we found a bunch of crystal structures in the PDB, and then for TTE GH1, unfortunately there is no crystal structure, and so instead it saved an AlphaFold model. And you can see all the structures are nicely organized in these folders.